The Army's need to know more and more about weather that surrounds this planet is a vital part of the expanded research program of atomic weapons. We all talk about the weather. The Army is doing something about the weather.
So we physicists are firing trillion-watt lasers into the sky to actually precipitate rain clouds and actually bring down lightning bolts. Even in the 60s, the CIA used this to bring down monsoons during the Vietnam War to wash out the Viet Cong.
In 1961, Congress directed the Bureau of Reclamation to begin a long-range study of cloud seeding with the aim of eventually augmenting the nation's supply of water. The program, called Project Skywater, continues at many sites throughout the United States.
Cloud seeding is booming. They anticipate at least another 200 ground cloud seeding machines to be put in before next season. We've been doing this since the 1940s and 50s. Other countries do it.
This is no coincidence whatsoever. They're doing this on purpose, and they do it often. But right now, I want you to focus on this big gap in between these two systems right now, the one that's coming in from the west and then the system we've just been dealing with. Take a look at this gap right in the middle of both of them. We have a counterclockwise spin effect going here, but at the same time, we have a clockwise situation going on right here. Watch this gap that is forming or has been formed in between system 1 and system 2, this clear line right here. I want you to notice the counterclockwise spin here and then the clockwise momentum here. I'll go back and we'll look at it together. You can see them spinning in different directions with the gap right down the middle. Now this gap is here because they are creating this gap, and I'm going to show you exactly when it starts. Right about here, you start seeing a static buildup. We also saw a significant radar beam right there. There is nothing natural about this beam. It has a cause and effect. And then as we move forward, you're going to see the entire area here become all staticky. Each radar tower from Texas through Oklahoma all the way up to the Dakota is going off at this point in time, creating a force field right in the middle of these two systems, one here and one here. All this little staticky looking stuff on the radar, that means all of these NEXRAD towers are being triggered at the same time. And now when we go back to this chart, it's going to be a lot easier to see what's going on here. So they want to separate these two systems, this one here and this one here, because if these two were to interact with each other, it would take away from the momentum that this storm is going to build up and then run across Texas in a counterclockwise motion after it fixes itself. Right now, it's in a clockwise momentum, and once this storm passes out this way, you're going to see this thing begin to spin in a counterclockwise direction, and it's going to start pulling up that moisture through Texas and Louisiana. And wait till you see, as we go through the days, we're at the 26th now. Here is the 27th, and look how this thing extends out. It's almost got fingers. These are the frequency waves I've been talking about. These are not physical waves in the respect that we see on this chart, 50 to 62 waves. There's nothing physical about this. This is a frequency or a technology coming from the Norwegian island, and sometimes it looks like it's coming from the coast of Antarctica itself. But look at this spread. It actually looks like it has a hand or fingers attached to it. This is the second time we're seeing this type of anomaly, different beams going in different directions. This is the exact thing I've been trying to explain. In my opinion, this is what's heating up the Atlantic Ocean. We have these beams going out in different directions. We've had severe weather events in all over Africa lined up exactly with each time we see the anomaly come out. We also had a very severe situation in Brazil. Look at these. These are straight beams of energy being pulsed in different directions, and now we are seeing the live effects of it. They will remove everything after today. You will not see this after 24 hours, I would say, but take a look at this now, document it, and share it as far as you can, because this means something. We're going to have some severe weather in Africa, Brazil, South America, the Atlantic Ocean, earthquakes, you name it. This could be all sorts of different things that take place. And one part that's new is we have a separate set, this wave anomaly popping off underneath Africa and to the east even farther. This is very important because we may see some situations take place in the Indian Ocean, Western Australia, and now the entire Western Pacific is also involved in this. We've had some high-level earthquakes in this area as well. Keep an eye out for more of those. But my friends, this is super important. This is not a glitch. It's happened about 8 or 9 times since February, and this cannot be ignored. I don't care what Ventus guy says. They play damage control and acknowledge this as a USO, as some people were saying, which is totally gaslighting my theory about this.
Because in 2002, Shortly after, like a lot of military veterans, I raised my right hand and I took an oath to the Constitution to hopefully do something meaningful with my life. 19 years old, unsure what I wanted to do. So I enlisted in the U.S. Air Force. My job in the U.S. Air Force was working in bioenvironmental engineering. So what bioenvironmental engineering is in the Air Force is equivalent to that of the OSHA and the EPA, if you're familiar with that. So we were an embedded liaison to make sure that we were tracking all of the aspects and impacts of the military, meaning what is the military doing and how is it impacting the environment, because we were accountable for that. Being government, we did not get any special treatment. We just couldn't be fined being another federal agency. EPA can, but not OSHA. So from the health side, it was knowing what you do in the Air Force. What does your job entail that is hazardous to your health? And I'm going to give you an example. Let's say that you were an aircraft painter, you were a mechanic. My job would go out to make sure I knew everything that you did, what you were exposed to, and how to mitigate and engineer out those hazards. Because we needed to, one, it's your legal right to be working in a safe and healthful work environment. So throughout 9 years, I worked as an industrial hygienist and an environmental specialist. There's 2 bases I was at that are called Air Logistics Centers. What does that mean? It's not like a fighter wing, it's not really fun and amazing. What they did is they took aircraft that around every 10 to 15 years, they were required to be dismantled down to the last screw. So that meant every single industrial process you can think about, checking the metal integrity, making sure everything's good to go, or sometimes overhauling equipment. Part of my job in tracking the health hazards was to look at any time someone wanted to buy a chemical, any type of chemical. It was ordered through a system, and in that system, I had to go in there and say, the country we're in, we're not allowed to use this. We need to substitute it out with something a little less hazardous, while also maintaining the integrity for a technical order, meaning for that process, it says you must use, xylene or toluene to do this process. Well, I have to kind of fast forward. I want to say around 2006, I started kind of opening my eyes to how the military wasn't really what I thought it was. And people approached me knowing what I did for a living and said, have you ever heard of? Well, I hadn't. And that sparked my interest. So I went online and I looked at details. I saw a lot of, debunking, a lot of sites that were just kind of calling it a conspiracy theory. And I thought, well, geez, this is what I do for a living. Preventive health, making sure that people are not getting sick, especially in the workplace, and by things that we're doing that can affect, human health and the environment. To summarize it, in an attempt to debunk this conspiracy theory as I thought it was, I didn't debunk it. It literally changed my life. Like I said, this is hard for me because it's not easy standing here and telling my story. One day I was going through that computer system, which if you want to look it up, it's called an Air Force Form 3952. It is the approval of hazardous materials. I was finding tons and tons of large quantities of aluminum, barium, strontium in the forms of oxides and sulfates.
Was able to take a number of flights where we could sample through these condensation trails or these confluent layers that had been laid out earlier in the day. So on the first sampling mission, we started at the Baltimore-Washington International Airport. The University of Maryland has a twin-engine Cessna that is a flying laboratory. It has a sampling nozzle at the front of the plane that collects air samples prior to any contact with the plane or the engines or anything behind. Those samples are then taken through a tube, pass through a filter cassette, and these filters are glass fiber filters that are pretty large pore space filters that do effectively capture ground pollution. So PM 2.5, those particle sizes are 2.5 microns, and they've done a really good job of it. But it's not really the proper equipment to completely evaluate the number of particles that might be smaller than that. And we're talking 10 to 100 times smaller than the PM 2.5 particles. But those do capture some of them. And we flew in an air-controlled zone and basically flew big circles trying to get to altitude, but the control towers wouldn't actually allow us to reach the altitude that we needed. They basically want you to pass through that zone. The second flight that we conducted was flown from BWI to Albany International Airport. All right, we're just in pre-flight here. This morning, we observed emissions from several planes, several high-altitude planes, flying between 25 and some up to 40,000 feet. and the trails that were left behind these planes spread out into a confluent layer, and the low angle of the sun in the morning allowed for us to observe the polarizing effects of those particles using simple polarizing lenses. We could see these obvious patterns that were being laid out in the sky. We were really thankful for the opportunity to be able to get up to altitude that we could observe these materials and sample that cloud layer. Our intention was to do a point-to-point sampling mission where we could actually reach altitudes, approaching 20,000 feet. Unfortunately, on our flight from BWI to Albany, the layer that we observed was at 27,000 feet, and I think we made it to about 23,000 feet, perhaps, and so we were below that confluent layer that we observed. We landed, had lunch, they refueled the plane. We have two blank control samples. One was taken prior to the flight, one was taken after the flight. So we should have, again, two blank samples and actually three samples, one on ascent, one at level flight, and then slight ascent from 17,000 to 21,000, and then change the filter and took another sample, a third sample, as we descended. And then on the return mission, though, we noticed that that cloud layer had descended from 25 or 27,000 feet to about 17,000 feet. So we could easily reach through that, and we sampled below the cloud layer, and I'm saying cloud, I mean an induced cloud layer. We sampled through that confluent layer and above it.
We're just about ready to go into the clean room facility. We will be looking at the samples by scanning electron microscopy. Scanning electron microscopy will provide information about the particle size distribution. We will be able to get some elemental analysis. What really this technique is for is to prioritize our samples for downstream, more advanced imaging, more high resolution imaging, especially by transmission electron microscopy. Put on a fresh pair of gloves. We're going to start with sample number 8. This is a blank that was collected on the return flight. No flow through this filter, so this filter should be free of any particulates. I'm going to use these scissors and forceps that have been cleansed with isopropanol and then acetone and wipe free with these dust-free cloths. These are the series of samples that we're interested in. These are samples number 9, 10, and 11. These were taken on the return flight where the plane passed through an induced cloud layer. Number 10, I believe, is the one that was passed through a cloud layer at around somewhere between 17 and 19,000 feet. I will take time to cleanse the instruments between each sample. Preparing sample number 9. Near the center. Opening it to ensure that the surface that had received the particulates is facing upward. Number 9 is completed. Now processing sample number 10. One additional sample. This blank sample was taken after the plane landed, and 3 of the samples containing actual airflow particulates had been collected. So we have one prior to the mission and one at the conclusion of the mission. Prior to imaging, these samples are coated with a thin layer of platinum. The platinum helps to take the excess charge or electrons and drain them off to the snub. And now we'll do the samples where we pass through the cloud layer.
A few little bright particles. This particle here is probably the one that we'll do the most analysis on.
So the general image that we're seeing now are the glass fibers from the glass fiber filter itself, and the bright particles or bright areas that we see are areas operating in the so-called backscatter mode of this microscope, collects electrons that are backscattered, especially from metal center compounds. But you can clearly see the lighter and darker contrasted areas there, suggesting that it's an aggregate. Mm-hmm.
Some of the smaller particles in here we're looking at on the order of about 450 nanometers long. But there's also smaller particles in there too. So backscattered electrons, typically the higher the atomic number, the brighter the signal. That being said, what we will do is look for the bright spots and then analyze those. The glass itself does seem to have sodium in it. Looks like aluminum, sodium, silicon, calcium, potassium. Mm-hmm. So the reason that caught my eye is because it's darker than everything else. And it's got lots of small particles in it.
Yep. And this gives us a lot of information. Again, it identifies which filters have qualitatively more materials, just, basically we see more material on it. It also gives us information about size of particles and potential for aggregates that we might be dealing with in the samples.
Barium sulfide again?
So barium sulfide is interesting. What he's doing now is just getting a high resolution image of it to see if this is indeed a single particle or if there's any evidence that there's an aggregate of smaller particles.
So really the big standout in this one seems to be iron. In this field we have one there, 2, 3, 4.
Yeah.
And I did analysis on all of them. They all seem to be pretty similar in composition.
Yeah.
Well, this is definitely made up of much smaller particles.
Yeah.
So this may be a clump of what you're looking for. We just analyzed 3 different areas. This particle seems to be high in aluminum. It's a large flake though. And this has some silver too.
Yeah, in terms of now the aluminum signatures that we're getting from the glass fibers themselves,
this is much bigger.
Much bigger.
So look at that.
Yeah, that's the aluminum.
It's easily 3x the silicon.
Yep.
And I think the silicon and aluminum are pretty similar in the glass. So here, if you look at just the glass fiber, silicon is significantly taller than aluminum. So that particle there is mostly aluminum.
Yeah.
So measuring this one right here, this is below 70 nanometers.
Right. Good. In the precipitation samples that we've seen in the past, the aluminum oxide particles that we've been seeing are on the order of 40 to 60 nanometers. So that's consistent with the size that we've seen from precipitation events. Again, these samples were collected directly from the air. There's not a lot of approaches or instrumentation that you can use to observe these nanomaterials. I mean, again, these are the sizes of, and so really the only equipment or instrumentation that is appropriate for identifying these materials is high-resolution transmission electron microscopy. This allows us not only to determine the size of the particles, we can also determine the composition using a technique called elemental dispersive spectroscopy. It's done within this large microscope. So it will give us information about the morphology of the particles, the composition of the particles, and we can actually see the crystalline spacing, so the spaces of the crystals themselves. So we are talking high-resolution microscopic techniques that are really the only way to be able to observe these directly. Morphology is important because the productions of these materials are really of a constrained size range, and we've seen this already in samples that we've analyzed from other sources. American Element produces lots of these nanomaterials, and you can actually purchase them online. The size distribution of these engineered particles are quite homogeneous.
What we get? Ooh, it's like it's aluminum. Now, what I've done is tell it to calibrate to the aluminum peak. So now what it's doing is going through each of its process times and each of its gain values and calibrating. Oh man! I can tell you this much. what I'm seeing right now is far superior to the last time I ran an operation. So you see you got two calciums, right?
Yeah.
All right. K alpha, K beta. All right. This variant B is probably an L and an M. Here's your major variant.
Yeah, and then you have the other confirmed. Yeah.
Correct. Variant is a triple quadruple.
It's definitely
Yeah. Oh yeah. Yeah.
The significance of the results is that, to my knowledge, this is the first evidence of nanomaterials collected directly from the emissions of aircrafts. This is the first time that this has been reported or acknowledged. So we conducted the analyses of these nanomaterials and conclusively confirmed that there were aluminum oxide, barium sulfate nanoparticles in the samples that we took on the East Coast on that second flight. For my mind, that would be sufficient, but I'm also was quite interested in, well, what's going on the West Coast? Are these similar types of results can be collected in various regions? I was really thankful to be part of a third sampling mission. We flew from near San Diego up to the Bay Area and back on one of these days where, again, there was clear evidence of patterned skies being induced by the emissions of aircrafts. In this sampling mission, there was a couple of different things. One is that we used a Learjet. It's a pressurized cabin, for one thing. We can get to higher altitudes. It's much quicker. And we used instrumentation that was appropriate for smaller particulates. We had instruments to monitor the air quality in real time. We had 2 particle meters on board, one that measured PM 2.5, so that would be relatively large particles that we're normally concerned about, these respirable particles that get into our lungs. But we also had on board a particle meter that went down to 20 nanometers. So that meter, combined with the larger particle meter, gave us a full assessment of materials ranging from 20 nanometers up to 2.5 microns. Our filters that we use were 0.1 micron, so that's 100 nanometer pore size. That would capture many more of the nanomaterials that were being released. What we're breathing in pressurized cabins is actually air from the outside. It's being taken in front of the engines. Some of the airstream goes into the engine to feed the combustion process, and then bleed air then off of that is taken directly from the outside, pressurized, and then is used to pressurize the cabin. And we could sample it right from the vents. So we had a sampling wand that we could hold up to the vent, and the sampling wand was sampling for the ultrafine particles. We sampled through one of these confluent layers, and as we passed through that layer, the larger particle meter basically read just ambient air within the cabin. With regard to the nanoparticle meter, there was clear evidence that there were smaller particles at significant numbers present within that layer. And that is significant. I mean, this is not only just the number of particles that we observed, but also that they were confined to that smaller size range. Above the layer, again, the air quality was quite good. Below the layer, air quality was quite good with regard to the smaller nanoparticle meters. But within that layer, there was clear evidence that there were smaller particles at significant numbers present within that layer.
And of course I knew that there's industrial processes you may not have heard of, but it's bead blasting, pneumatic sanding, shot peening. There is certain medias that's similar to that is used. However, I had already accounted for that. I would sit and look at this computer system and say, this shop wants to order this paint. I'm gonna tie it to a task. We had to know what was being used, why it was being used, tracking it cradle to grave, and how we were gonna dispose of it to be compliant with OSHA and the EPA. One of the legal requirements in approving these is looking at what used to be called the material safety data sheet. On that sheet, it's going to list the manufacturer. It's going to list some maybe required personal protective equipment that needs to be used or some ways to mitigate the exposures. These electronic MSDSs did not have a manufacturer name. They were very vague. They almost looked to me like somebody had made it and scanned it into the system. So I asked the question, what is this being used for? I never got an answer, so I didn't approve it. And it sat there. And then the heat came down. Why aren't you? Are you behind on your 3952s? Only a select few of us did that. So I started asking questions. And at that point, my demonization began. You know, I made my rank. I was decorated. I was a non-commissioned officer of the quarter. I won lots of awards. I had no reason for anyone to attempt to demonize me. So then I get moved over to the other Air Logistics Center. There's only 2 in the Air Force, which is in Warner Robins, Georgia. This kind of carried with me, and I thought, you know what? Should I revisit this? Is it worth it? Did I hit something? Maybe it's need to know. I started finding the same things at Robins Air Force Base. I was now doing some more investigation work. Part of what I did was to use a high volume air sampler to air sample up to, I'd say, a football field in about 10 minutes. I also conducted soil sampling because I thought, you know, if this is real and they are spraying this, it's gonna get to the ground. So I conducted air sampling, I conducted soil sampling, and I was getting high levels of these contaminants. When I started asking the question again under a new commander, I never in my life thought I would have somebody look me in the face and tell me, I am questioning you. Is there something wrong with you? You've been looking really depressed lately. You know I can put you under mental evaluation for up to 120 days. Who would take care of your daughter? Because I was divorced at the time. As soon as I heard that, I knew. It validated everything I ever thought. And I thought, I've spent 9 years of my life trying to protect human health, and here we are, violating law after law after law. Just sitting here, instead of protecting the people, we are poisoning the people. But what I want you to take from this is to understand that I am being completely honest with you, and that geoengineering is occurring, it's been occurring, it is not new, and your tax dollars are funding this.